So today, before I ask you to practice a little bit further with these questions, I'm going to go through the homework solutions to questions 1 to 6, which you had last night. So I'll go through all of them, and do please let me know as you're watching it if there's something that's not clear or there's something that you don't understand. So, I asked you to do questions 3, 4, 5, and 6. So question 3, we had 4x squared minus y equal to 0, and 2x plus y equal to 2. Now we must identify which one is the line and which one is the curve. This one has a power, so it's the curve. It's not always on top, so you can't just assume that the first one will be the curve and the second one will be the line. Then the first step is to write what we say. So far we've always written x in terms of y, but this one is easier to write as y in terms of x, so y equal to 2 minus 2x. If you wrote x in terms of y here, you would have gotten a fraction. You'd have had 2 minus y all divided by 2. So this is easier, and especially as I can just replace the y here without having to square out anything. Now, it works out either way. It doesn't actually matter which one you replace, and sometimes you can't avoid fractions. So as we go through more of the examples, you'll see sometimes we have no choice. But as this is simpler, I'm going to isolate y. So in this case, I'm isolating, getting it on its own, y rather than x, because it's simpler. But if you didn't notice that, you will get the same answer either way. So then I'll sub in into my curve, I replace y, and I get 4x squared minus y. I must have the minus outside the brackets like this because it's going to change both of the signs inside the brackets there. And this is going to give me 4x squared minus 2 plus 4x equal to 0. And because I can divide across by 2, I will. Giving me 2x squared plus 2x. I'm going to rearrange as well to do x squared, x constant, minus 1 equal to 0. And I can either solve this by my minus b formula or by factorizing. This one I'm pretty sure has factors. No, I can't see them. Let's use the minus b formula. X will be minus b plus or minus the square root of b squared, 2 squared, minus 4ac, and c is minus 1, all over 2a. So then we'll put this part into our calculator in one go. We've got 4 plus 8 square root of 12. So, we're going to have a square root in our answer. Square root of 2 squared, which is 4, minus 4 by 2 by a negative 1. And that gives me 2 times the square root of 3. Now, that's probably right, but just because it's a little of an unusual answer, I'm just going to check, first of all, that I've taken it down right. 4x squared minus y equals 0, 2x plus y equals 2. Good, then that I've manipulated it right, the 2 stayed where it was, minus 2x came over, that I've substituted in correctly, which I have, changed the sign, and then I divided by 2, 2x squared, 2x minus 1. That's right. So then x will be minus 2 plus or minus 2 root 3 all over 4, and we'll fill into our calculator to get the plus and minus answers for x. So we have minus 2 plus 2 root 3 all over 4, and I get minus 1 plus the square root of 3, minus 1 plus the square root of 3 over 2, and when I fill in the minus I get the same thing, but with a minus the square root of 3 over 2. So we get 2 answers like that. Now, if you went ahead and changed those to decimals, that's fine. And then you'll sub them in and you'll get a decimal answer for y as well. So I'm going to leave them as surds though, because sometimes we're asked to work with surds like this. So when x is equal to minus 1 plus the square root of 3 over 2, y will be 2 minus twice minus 1 plus the square root of 3 all over 2. You can put this into your calculator, or you can notice that those 2's will divide in and cancel, and the minus will change the sign. So y will be 2 plus 1 minus the square root of 3. Y will be 3 minus the square root of 3. Is that something you have to be able to do without a calculator? No, because we have a calculator. So 2 minus 2 brackets, 2 minus 2, type in my brackets, my fraction, negative 1 plus the square root of 3 over 2, like that. And that is 3 minus 3, which I got. So those are my x and y values there. And when x is minus 1 minus the square root of 3 over 2, y will be 2 minus twice minus 1 minus root 3 over 2. The same thing happens, and y will be 2 plus 1 plus the square root of 3. Y will be 3 plus root 3. And again, the calculator can do that for us, and we can just come back and change this to a minus sign, giving us 3 plus the square root of 3. Again, if you used decimals, if you converted these answers to decimals to 2 decimal places and filled in, that's perfectly fine as well, just using the change button in your calculator. Okay, question 4. We have y equals x squared minus 6x plus 5, and we have x plus y minus 1 equal to 0. So again, which one would be easier to replace? I think it's clear to see that if I replace x, I've got to do some squaring out and I might make more mistakes. So I'm going to isolate y again here. Y is equal to, bring the 1 over, 1 minus x. So there's my star equation. And I'm going to replace y up here. So I get 1 minus x is equal to x squared minus 6x plus 5. I'll bring everything to one side. 0 is equal to x squared minus 6x plus x plus 5 minus 1. And I'll write it the other way around. So my quadratic is x squared minus 5x plus 4 equal to 0. Solving that using the minus b formula, x is minus b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to put this into our calculator in one go. The square root of 25 minus 16, which is the square root of 9. It should be 3. Let's have it. Let's check though. So we have the square root of 25 minus 4 by 1 by 4, and we get 3. Good, no surds this time. Because we could have done this by factorizing as well. Could we? X is going to be 5 plus or minus 3 over 2. So we'll either have x is 8 over 2 or x is 2 over 2. So x is 4 or x is 1. Okay, my factors would have been x minus 1, x minus 4. For some reason I just wasn't seeing that today. And then we fill back into here. So when x is 4, y is 1 minus 4. So y is minus 3. and I have the point 4 minus 3. You don't have to write it in point formation. And when x is 1, y is 1 minus 1, so y is 0. Unless you're asked for, you don't have to do that last step there. It's good to keep in mind that these simultaneous equations are giving us points of intersection, of course. Now, question 5 then, we'll move right on. We've got a circle, x squared plus y squared equals 25, and a line, x plus y equals 7. And this time it doesn't matter which one I isolate, it's exactly the same amount of work. So x is equal to 7 minus y. That's my star equation. And I substitute into the curve. Instead of x, I now have 7 minus y, all squared, plus y squared. I'm bringing the 25 over at this point as well because I know that I'm going to have a quadratic equation when I'm done. Square the first, square the last, double the product, plus y squared minus 25 equal to 0. And y squared plus y squared, 2y squared minus 14y. 49, take 25. 49, take 25, gives me 24. It's a plus 24. And because I can divide across by 2, I will. Y squared minus 7y plus 12 equal to 0. And I can see the factors there. Y minus 5, y minus 2. Nope, I can't see the factors. 3 and 4. Y minus 4 and y minus 3. 5 and 2 did add to give me 7. Minus 5 and minus 2 added to give me minus 7. But they didn't multiply to give me 12. So I was getting ahead of myself there. Y minus 3 and y minus 4. So the two values are y equals a plus 3 or y equals a plus 4. And filling back into my star equation, when y is equal to 3, x is equal to 7 minus 3, so x is equal to 4. And I have the point 4, 3. And when y is equal to 4, x is equal to 7 minus 4, so x is equal to 3. And we have the mirror point, the point 3, 4. And those are the 2 points of intersection of this line and this circle. Okay, final question then was question 6. Just move this down. So for question 6, we had 3x squared minus y squared equal to 3 and 2x minus y equal to 1. So here's my line, here's my curve. Which one is easier to write in terms of the other? Well, I want to avoid having a fraction if I can. So, but we'll get the same answer regardless. So if you did work with the fraction, that's fine. And I'll say that minus y is equal to minus 2x plus 1. And then I'll change the signs as well. So I'll change this to a plus, and this to a minus. And my star equation will be that y is equal to 2x minus 1. I take that and substitute it into my curve, giving me 3x squared minus 2x minus 1 all squared minus 3 equal to 0. It's really important that you only replace the letter, and the minus is outside the brackets and the power of 2 is outside the brackets. Then, by the rules of BIMDAS, we square first, then we apply the minus. So this gives me 3x squared minus bracket, square the first, double the product, square the last, minus 3 equal to 0. And 3x squared minus 4x squared plus 4x minus 1 minus 3. So what happened there? This minus really represents a minus 1. So minus 1 multiplies each of those terms there. Now, gather like terms, we've got a minus 1x squared plus 4x minus 4 equal to 0, and I'll change the signs because it is easier to factorize. It's easier to factorize once I have a positive number in front of the x squared. Okay, so there's equal roots. I just have one value for x, which is that x is equal to 2. And I can sub it straight into my star equation. So when x is equal to 2, y is equal to 2 by 2 minus 1, which is 3. So y is equal to 3. And we have the point 2, 3. And that's the final solution to that. Now, before we move on to the next topic, I'm going to ask you to do a little bit more practice with this. And I'll upload all the solutions to that, and then we will move on to the next topic in algebra. Thank you.